Okay, today we will be simplifying radicals using prime factorization. So I have created 3 steps in simplifying radicals using prime factorization. Alright, the step 1 is factor the radicand. In this case, the square root of 24. 24 is what we call the radicand, so we would factor 24. Step 2 would be to circle the pairs. Place one number from each pair outside the radical. And step 3 would be to underline your non-pairs and then place the non-pairs under the radical. So these are the 3 steps that I have created. We'll start with our first example, the square root of 24. Okay. So when I say prime factorization, that means find the prime numbers that can go into 24. Prime numbers are numbers that are, the factors are that number and 1. So I would look at the prime number 2, which the factors are 1 and 2, because 24 is an even number. So I would break 24 apart, and I will ask myself, 2 times what gives me 24? Okay? I like to cross this out, the radicand out, because I'm done using that. So now I'll look at 12. Because if I factor 2, you only have 1 and 2. So I want to break 12 down to all prime numbers. So 12, I'll use 2 again because I know it is an even number and 2 goes into 12 6 times. Again, I cannot break 2 down anymore because it's a prime number. It's just the factors are just 1 and 2. So therefore, I will break 6 down, which is an even number. So I would divide it by 2. 6 divided by 2. So 2 go into 6 3 times. Alright, so now I have all prime numbers. This is what I mean when I say prime factorization. Now step 1, I completed step 1 by factoring the radicand. And I'm going to cross 12 out because I don't want to get confused, 12 and 6 out because I've broken them down. So I'm left with all prime numbers. Alright, step 2 says circle your pairs. I have a pair of 2's. Then it said after circling your pairs, place one number from that pair. So I have one set of 2's, so I will place 1, 2 outside the radical. Step 3 says to underline your non-pairs. And when you underline your non-pairs, you're going to place them up under the radical. So I have 2 that does not have a pair and 3 that does not have a pair. So I'll place them back up under the radical. I have one set of 2's, so I place 1, 2 outside the radical. So what I have to do now is multiply what's up under the radical. So my answer is 2 square root of 6. Alright, so let's look at another one for using our same steps. Let's look at the square root of 32. Again, it is an even number. So I would start with 2 because I know 2 is a prime number and we're using prime factorization. So 32 going to 32, 16 times. I cross out 32. Okay, I can't break 2 down anymore, but I can break 16. And I go again, an even number. I would start with 2. 2 times 8 gives me 16. Cross that out because I'm done with that. Alright, 2, can't break it down anymore, so I have 2 and 4. Okay, so I can't break 2 down, but I can break 4. So 2 times 2. I'm done factoring those out, so now I'm left with all prime numbers. Okay, now step 1 has been completed because I have factored the radicand, which was 32. Step 2, I need to circle my pairs. 1 pair of 2, 2 pairs of 2. So since I have 2 pairs of 2, I will put 2 2's on the outside. And then it says underline your non-pairs, which is only thing left is a 2. And I'm going to place that on the inside of the radical. So now I just perform the operation of 2 times 2, which is 4, and square root of 2. 4 square root of 2. Okay? Let's look at another example. Square root of 48. Again, let's try a different prime number. Let's try 3. 3 can go into 48 16 times. And I'm going to cross that out. Alright? 2 is a prime number. And that can go into 16 8 times. Cross that out. Again, we have 2 times 4. And then factors of 4. 2 times 2. Circle our pairs. We have a pair of 2's down here. A pair of 2's up here. Underline what's left. So my pairs go on the outside, which is 2 times 2. Square root of what's left. We underline what was left, which is 3. So the simplified form of this radical is 4 square root of 3. Okay. Now, what if we have a coefficient out front of the radical? If we have a coefficient out front of the radical other than 1, what do we do here? We still follow the same steps. We're going to factor the radicand, which is 12. 2 times 6. Alright, we can break 6 apart again into some prime numbers. So we're done with those. So we have 2 times 2 times 3 pretty much. But this time I have a coefficient of 2 outside of the radical. So I'm circle my pairs. So along with that coefficient of 2, we have to write another 2 because we have a pair of 2's. We underline what's left, which is 3. So our answer is 4 square root of 3. We cannot leave this 2 out. We have to bring it over. Okay? Let's do one more. Let's do 4 square root of 44. Okay? I'm going to go ahead and bring that 4 over because it's already outside of the radical. Then I'm going to break down 44, which is 4 and 11. Cross that out. We can't break 11 down because that's a prime number. 1 times 11 is the only factors. Alright, so but we can break 4 down into 2 and 2. Circle your pair. So we're going to bring that pair up here and put outside with the 4. But we have an 11 left. And that goes up under the radical. So my answer is 8 square root of 11. Alright, stay tuned for the next video on simplifying radicals using perfect squares.